Good morning, Hacksters! I'm very excited to be back on screen with Archimedes, my companion bot, and he's helping me co-host this morning's event, which is our Hackster Impact Spotlight on the subject of robotics, so I couldn't not bring my own robot. So excited to be invited by the Hackster team to present these today. So this is a series, as you may know, celebrating Hackster community members and all of their amazing projects. So we've got 4 coming up for you today. We've got a cute desktop companion robot, an automated read organ, an obstacle-avoiding educational bot, and a personal office assistant with a personality. So we're going to be seeing 4 presentations from Hackster community members describing their own projects and also showing them off, which is very exciting. If you're excited about this kind of thing, you can join the robotics community, publish your own projects to it just by tagging them with robotics. Similarly, there's a community dedicated specifically to companion bots, including Archimedes and a bunch of Archie's friends from across the years. We also have a couple of ongoing giveaways. So there's the Edge AI giveaway, which I believe is still ongoing until October 5th, with not only a ton of really cool hardware prizes, but also a mega prize, which is the ultimate home AI server giveaway. And then also the new Amp Up Your Workstation giveaway with Autodesk. So you can go to Hackster.io/contests in order to find these. There are also other contests going on. The Edge AI Earth Guardians contest is going on for just a few more days here, ending on September 30th. So be sure to get your entries in for that. You could be sent to Taiwan. Be amazing. As well as a few challenges for our pros. If you're not familiar with the pro program, go to hackster.io/pro and you can become a member of this community and get contracted to do really cool projects and content like this and stuff. Anyway, brain fart. So check those out. Also, as a side note, this weekend I'll be presenting and bringing Archimedes to Maker Faire Bay Area. So if you want, you can use the code SEEME, all one word, to get 35% off a day or weekend ticket. You can also watch live online on Make's YouTube channel. And finally, I just wanted to share Archimedes' history with Hackster. So back in 2018, I built this for Maker Faire Bay Area in May. So he's just about 7 years old by any measure at this point, and I would like to say happy birthday to Archimedes. So I'm going to be attempting to have him help me present these spotlights, but we will see. The one rule of robotics is that Archimedes is a diva, and so we'll see if he actually wants to participate this morning.
Hey, my name is Archimedes.
Hey!
You may know of my great-great-great-granduncle and namesake, who was Merlin's familiar. Now, if I may
that's about enough. Okay, he does tend to sort of go on a little bit, so I gotta kind of cut him off one from time to time. Okay, let's go into the first presentation, which is a cute desktop companion robot. Let's go.
From Kenya, and I'm currently a final year mechatronics student, and I really thank the Hackster team for giving me this opportunity.
Pardon me, I'm going to restart.
My name is Nixon Kiprotich from Kenya, and I'm currently a final year mechatronics student, and I really thank the Hackster team for giving me this opportunity to be able to tell you about my project. So I am an IoT and robotics enthusiast, and I contribute to a lot of open source projects as well as building my own project. So today we are going to talk about TN24. So TN24 is a cute desktop companion robot. So when building this project, I was thinking of how like if someone would like to get into robotics and like, okay, the main inspiration for this project was I wanted to get into robotics, but not like in a very complicated way. So I was thinking of a affordable and simple project to get me started. So I decided to settle for this. So the robot. I'm going to tell you more about the project. So as you can see, it's actually cute as the name suggests, and it's battery powered, but it's also rechargeable. So once the battery is over, you can recharge it. Let's get into the inside of it to see how the robot looks like. The first version of the robot was made of cardboard, but later on I decided to make a 3D printed casing for it. So this is how the casing looks like before everything is assembled. So initially I'd settled for this to hold the servos, but I later noticed that they were necessary. That's why you can see it in this version. Yeah, so the servo motors just snaps in directly the way you can see it here. You can be able to remove it and push it back again. Yeah, I also used an OLED like this one, and for the brains, it's just the same as this one, the Shear ESP32S3. So I think it's time I show you how the robot looks like in action. So you can see as it boots up, you can see the name TN24, then it immediately goes to sleep mode. So to wake the robot up, you have to tap it like that. Yeah, then the robot now wakes up and starts moving. Oops, so we're having a problem with one leg, but we'll look into that later on. This is the project that you can work on it for a weekend, because the 3D printing for this only takes 6 hours to print everything, and then after that, assembling is quite simple. Like I've shown you, the servos just snap in. So I'm very thankful for the Hackster Impact Spotlight team for giving me this opportunity to showcase my project. And you can find me on all social media at Technique, as you can see here at Technique. Follow me, and to get updates on all my projects. And on Hackster.io, you can just go there and search Dixon Kiprotich or Technique, and you'll find most of my projects there. And yeah, my projects are normally quite simple. I always try to find a way like to make projects simple in a way that anyone can understand and anybody can replicate. So go check out the projects, like them, and support my work. Thank you so much for this opportunity.
So cool. All right, so we have a comment here saying, it's nice seeing the internals not totally overstuffed. The number of times I've struggled to fit everything into an auto, that is incredibly real. So I will be pulling these projects up after each presentation. So this one is this adorable little bot with a face, and indeed plenty of room in there for the internals. So there's no like issues with overheating. I've got to mention that Archimedes doesn't even have an enclosure, really. He's got this chassis here, but like everything's pretty much just strapped to my shoulder. I'm going to be remaking that, but it'll still be kind of like open air robotics. Oh, he's trying to assault my face as usual. Anyway, super cool project, and you can check out more of Nixon's work on Hackster.io, as he mentioned. So just go look at this tiny DIY game console. Ah, so much cool stuff. Okay. But we have things to get through, so let's check out the next one, which is, well, I can't even explain this one. It's so good.
Well, that was in a nutshell what this presentation is all about. You saw some hobby servos pulling the keys of a reed organ, a lot of servos, 61 to be precise. And maybe you saw 4 PCA 9685 boards, which enable this huge amount of servos working together. Sure, you can figure out the rest of it. A microcontroller somewhere controlling everything, a power source somewhere, some mechanism to get the air moving. If all this became clear to you by now, the rest of my presentation is redundant. But here we go. My name is Johan Halmén. I'm a music teacher teaching kids from 6 to 18 in a small town in southern Finland. Besides music, I'm interested in computer stuff. I used to love coding computer games for fun, but this interest has slowly shifted to microcontrollers and the possibilities they open. It kind of became more fun to build actual machines than to just simulate things on a graphic screen. Some of my machines have been related to music somehow. A robot sweeping through a row of chimes. 2 different kinds of mechanical glockenspiels. A theremin. A laser string guitar. A busker organ. And this Orguino, the automatic reed organ. Thinking about the kind of computer games I used to write, I found great joy in designing the graphics and writing the music, but as well as simulating something on a graphic screen. Also, the music was kind of simulated. I just wrote it in some MIDI editor. Then a chip played the music. Very dead music in every sense. But turning a real acoustic instrument into an automatic instrument kind of gives the extra human touch somehow to everything. The great fun of making real instruments automatic, like this magnificent reed organ from 1902, is trying to preserve the most of it and still make it play by itself. To convert a reed organ into an automatic one, we need to know the basics about the instrument. First of all, a reed organ doesn't work with overpressure, but with underpressure or vacuum. A pair of bellows normally suck the air out of a so-called magazine with a spring-loaded backboard. The magazine being a kind of a large bellow itself, but a sucking one, not a blowing one. To make it automatic, I drilled a hole in the back of the magazine and attached a vacuum cleaner to it. It's very noisy, and that's kind of the thing I really need to work on somehow. So, a servo motor is attached to a key by a piece of thread which is attached to the servo horn. One angle for key up and one angle for key down. To do the calibration, I used an Arduino Cloud dashboard. When everything was built and the servos got calibrated, it was time to put the music into it. I created the following workflow. I start by writing music using MuseScore. I use an Arduino Leonardo connected to my computer. I play the music in MuseScore, and the Leonardo records all MIDI events, reading them from MuseScore via USB. From the listing, I create data arrays which I can hard-code into sketches for the MCU that will control the reed organ. Lastly, I would like to place this automatic reed organ on a public place somewhere. I would place a QR code there which takes a casual passerby to a site where they can wish for melodies for the organ to play. Each wish would cost $1, €1, whatever, and the money would go to charity. A fully automated busker organ. Thanks for watching.
That video was a work of art. I'm gonna have that song stuck in my head for absolutely the rest of the day. What an amazing bunch of collection of things to be looking at. So, as before, you can find Johan's tutorial on Hackster.io, and I've just been looking at all the different parts that went into this as he was giving his talk, and he mentioned a number of things. For one, it's a very brave move to essentially start out by saying, if you already know the basics, then the rest of my presentation is redundant. At the same time, he talks about it being noisy, and just looking at the amount of servos on this thing, and also the addition of the vacuum, which I didn't realize. Of course, you're going to have a lot of background noise, but I feel like that just is sort of what makes this a brilliant choice of instrument for this project, is that it is so loud, almost certainly, that it's likely to drown out all of the other stuff that's going on. Archimedes, on the other hand, does constantly make servo noises happen in my ear, and I've turned him off for this, but we shall see. Lots of other interesting and weird projects from Johan as well, including this ballot sorter robot. Like, just go dig into the project history here, because there's so much interesting weirdness, which is what I love about this community. All right, our next presenter, Dr. Carlotta Berry, has been a guest on Hackster Cafe before, which is my occasionally every other Tuesday an interview show that I do with people doing awesome stuff in electronics in the Hackster community and beyond. So she is the creator of Noir Steminist, and just an educator who publishes an incredible amount of material helping out the community and helping people learn how to build robots. So I'm very pleased to welcome our next presentation from Dr. Carlotta A. Berry. Let's go.
Hi, my name is Carlotta Berry, and I'm a professor in the Lawrence Giacoletto Endowed Chair of Electrical and Computer Engineering at Rose-Hulman Institute of Technology. I also teach human-robot interaction and mobile robotics. I am also the director of the Multidisciplinary Educational Robotics Lab, where I am currently sitting, and I'm the owner of Noir Steminist Educational Consulting, LLC. My research is in robotics education, engineering education, human-robot interaction, and open source robotics. The reason that I do open source robotics is because one of my goals is to diversify the engineering profession by recruiting, retaining, and developing more historically minoritized and marginalized people to STEM. And I do that with robotics. I bring my robots to people to bring them to STEM, and I bring robotics to them to bring STEM to them so they also can see themselves in STEM, because representation matters. One way that I'm able to diversify STEM is by doing work in open source robotics and taking away the barrier, including cost, so that people don't have to break the bank in order to do robotics, and taking away the knowledge barrier by freely sharing my knowledge, so that if you have a desire to learn about robotics and artificial intelligence, then I'm here to help you to do that. I am very active on social media using my STEM is for the streets hashtag and know our STEMinist because I need to go where the people are in order to diversify the profession. So some of the things I do is I have AI avatars that teach about robotics. I do engineering quizzes. I do engineering demonstrations. And I also take my open source robots, the flower bots, into museums and libraries and schools to do workshops for K through teachers, K through 12 teachers, to teach them robotics, as well as kiddos as young as 6. I've done workshops for Girl Scouts, Boy Scouts, Boys and Girls Clubs through the organization I helped co-found, Black in Robotics, and through my company. And I also do workshops for adults as well, makers. So I've done some for K through 12 teachers as part of professional development to help them to learn about robotics and AI, to teach them how to build and program a robot that they then can take back into the classroom to show their kiddos and help to get them excited about the possibilities of exploring STEM. I also write children's books about kids and robots, learning to use them, build them, program, and fix them so that they can become critical thinkers and use their curiosity and creativity and innovation to create the world that we hope to live in by changing the face of STEM so they know it looks like themselves. The reason that robotics is ideal for bringing people to STEM and bringing STEM to people is because it is multidisciplinary, intersectional, and interdisciplinary. Because a robot is a mechanical system given intelligence with software that uses sensors in order to make decisions, and it interacts with people. So all of these disciplines are seen in a robot. So the multidisciplinary nature of robotics is a benefit, but there are some challenges, including the high cost of robotics platforms, limited flexibility and accessibility, and the need for a strong knowledge base and structured learning activities. This is so important because it is multidisciplinary, so people come from many different backgrounds and have many different prerequisite skills. However, this also means that it is possible for robotics to change the face of STEM because it is so easy for so many different people to see themselves in a robot. One way that I'm able to diversify STEM is by doing work in open source robotics and taking away the barrier, including cost, so that people don't have to break the bank in order to do robotics, and taking away the knowledge barrier by freely sharing my knowledge so that if you have a desire to learn about robotics and artificial intelligence, then I'm here to help you to do that. I am very active on social media using my STEM is for the streets hashtag and know our STEMinist because I need to go where the people are in order to diversify the profession. So some of the things I do is I have AI avatars that teach about robotics. I do engineering quizzes. I do engineering demonstrations. And I also take my open source robots, the flower bots, into museums and libraries and schools to do workshops for K through teachers, K through 12 teachers, to teach them robotics, as well as kiddos as young as 6. I've done workshops for Girl Scouts, Boy Scouts, Boys and Girls Clubs through the organization I helped co-found, Black in Robotics, and through my company. And I also do workshops for adults as well, makers. So I've done some for K through 12 teachers as part of professional development to help them to learn about robotics and AI, to teach them how to build and program a robot that they then can take back into the classroom to show their kiddos and help to get them excited about the possibilities of exploring STEM. I also write children's books about kids and robots, learning to use them, build them, program, and fix them so that they can become critical thinkers and use their curiosity and creativity and innovation to create the world that we hope to live in by changing the face of STEM so they know it looks like themselves. So my flower bots are named because I want my robots to grow with the user. So as their skill sets improve, I want them to have the same modular robot that they can then 3D print new parts for to grow with them. So it works with several different controllers, and the robot is called Flower Infinity Bots, Lily Infinity Bots, and so on, because I want them to know that there's infinite possibilities of what they can do with the robots. My open source materials are available everywhere, including my social media, GitHub, YouTube, and of course on Hackster.io.
So this is the microbit with the motorbit expansion board, and this program runs both wheels, uses the sonar, it uses a buzzer, and it uses the LED. So the way it works is it will run forward, it will move forward until it sees an object that's close, and then it will stop, turn the LEDs on, and start playing the Happy Birthday song. It only uses one 4AA battery, and then it's using the motor controller that's built into the expansion board. So here is the robot moving.
So here's an example of the learning and growing curriculum for a FlowerBot, where you start at the very bottom as a novice, learning either Microbit or Circuit Playground Express with graphical make code that may then later transition into Python with maybe just one sensor, a sonar. Then you move up to Circuit Playground Express. You may add on another sensor like light following sensor or a temperature sensor, etc. And then as you continue to grow up to the advanced level, you may do Arduino Uno or ESP32 and move from the graphical-based programming to text-based like C++ or Sketch. Then as you move into the expert level, you may move to Raspberry Pi, PicoW, ESP32, MicroPython, or the microcomputer, and you may add on something like a camera. So this is an example of the robot growing with you, where here over on the right I have shown an example of MicroPython, C++, as well as Scratch and MakeCode. There's also a graphic that shows the modularity of the robot. So how about we take a look at a few of my robots? The first one I'm going to share with you today is going to be a Lilybot with a microbit and a motor bit. This is the one I use for my novices. So for my brand new people to robotics, such as my littles who may just be getting started with coding, building, etc. So we will program this motor bit and microbit using make code, which is similar to Scratch. It's block-based or a puzzle-like programming. And this robot we would build and then add a sonar sensor, for example, to do obstacle avoidance. Some teachers then told me that their kiddos had outgrown microbit and could I do something with Circuit Playground Express? Well, of course we can. So for more advanced elementary school kiddos, here is another Lilybot with a Circuit Playground Express and a Cricket for a Circuit Playground Express. So this one you can do a little bit more high-level coding. With both of these make code robots, you can also program them not just in the block-based code, but also in Java and possibly Python. So here is one that was doing obstacle avoidance this weekend at the Indiana State Museum. So there would be Lilybot with a Circuit Playground Express Cricket. You can also get a Cricket with a microbit to expand it, and you can also add an AI engine to a microbit to expand it. So that's on our list for one of our future iterations for the microbit. The next level up, maybe when they get to high school or middle school, is to add an Arduino. So we've had a Lilybot and DaisyBot be used for high school competitions, where one was an Arduino Uno and the next level up of the robot we used an Arduino Mega. So that's another way that we're able to expand our robot, by also growing with the Arduino family, depending upon the capabilities of what the kiddos want to do with the robot. This one has been used in a competition with an infrared remote and an infrared receiver in order to have the robot navigate through an obstacle course. And finally, here we have Lilybot with a Raspberry Pi PicoW. This one has a battery pack. Notice it has breadboard. So we do put breadboards when we need to do electronics wiring. The PicoW mount, upper chassis, lower chassis, the two wheels, the motors. Here are caster wheels in the lower chassis, and then the module for the power bank. And then our final robot, our ESP32. This is our newest baby to the bunch, so we don't have the code fully written for this one in the Raspberry Pi 4B quite yet. But there's the ESP32 and the breadboard with the upper module, the upper chassis, the wheels, the motors, a different kind of power bank, the caster wheels, and the lower mount. So I started working on this idea for this design probably during the pandemic, even before I got the Open Source Hardware Trailblazer Fellowship from the Open Source Hardware Association, but getting that really helped me to expand my idea and to grow quickly. So probably refining the design, it's constantly an iteration because engineers never stop growing and improving. We're probably on about version 5 of the robots at this point. But once we have a design that I'm pretty happy with, I can typically 3D print the parts in 2 or 3 hours, build one in about an hour, and then depending on what we're wiring and coding, that may take a couple of hours. When I do workshops for people, I typically can help someone build a robot in an hour and a half, and maybe within another hour, we can have the robot moving on the floor and possibly avoiding obstacles or tracking light or doing something else. So here's an example of our bill of materials. It is also available on our GitHub as well as on our Amazon list. And we also have a spreadsheet of it, but obviously because we go through so many iterations of the robot, there's a lot of flexibility here, and it is modular, so we want you to be able to create and design your own parts, but this at least gives you a beginning. You're going to have to 3D print a lower chassis, upper chassis, as well as a controller mount and power mount, depending upon which controller and which power you want. You're going to need 2 DC motors, 2 TT wheels, as well as 2 half-inch caster wheels and about 14 M37 millimeter screws and 2 5 millimeter screws, and these are pan head screws. 2 mini breadboards. Those also are dependent upon whether you need them. You don't really need them for the Circuit Playground Express or microbit. And you need a TB6612 motor driver for the Arduino, the Raspberry Pi, and the ESP32. The power requirements are dependent upon the controller as well. So you could have a 4 AA pack, 3 AA pack, a 9-volt battery pack, or a power bank. And then, of course, whichever controller you would want to use, Circuit Playground Express, microbit, Arduino Uno or Mega, Raspberry Pi Pico W, ESP32, or Raspberry Pi 4B. So over here on the right, we've given a couple of graphics for assembly as well as the video for how you put the robot together. This is available on our YouTube channel, and it is also on Hackster.io. So you can go take a look at this. Like I said, as the versions change, there may be some small tweaks in the steps, but overall it's pretty similar. Some of the challenges we faced. There are lots. A couple of them have to do with making sure the robot stays level with the floor. Sometimes with the motors, with 3D printed parts, they're not repeatable always. But I don't want to change away from 3D printing because I think it is low cost and it's a great, like I said, way for people to make new parts for the robot, and making it modular helps the robot to grow with them. But coming up with a design where we could keep the motors in the lower chassis and keep them from rocking too much, and keeping the caster wheels as well as the DC motor driven drive wheels flush with the floor. So we've had to change the lower chassis several times to do that. And then one thing I did this weekend that unfortunately I've also done before is I've left robots in my car. The car got too hot and it has warped the chassis. So things we're working on for the future. I am going to try out this new HTPLA GH from Polymaker, as well as PET-G. And then I'm going to try to anneal the lower and upper chassis of the robot after we 3D print it, to see if I make the mistake of leaving robots in my car again, they don't get so warped that I can't really use them anymore because they no longer are level with the floor. So the drive wheels don't make enough contact. The caster wheels are below the drive wheels. Other things we're really working on, I've already shared. The microcomputer. We're trying to see how far we can grow this robot with the Raspberry Pi, just like I have a student working on the Raspberry Pi Pico W, to see how advanced of AI can we do. Can we go from SLAM to something with color tracking? Can we do some swarming, where the robots do some heterogeneous or homogeneous robot collaboration to do mapping or to solve a problem or to work together, such as reconnaissance, where it goes and finds things, or by putting the gripper on the robot, can one robot wirelessly communicate with another one to pick things up? I also have a student who's working more on my K through 12 outreach robots by showing how you can use PictoBlocks to program Arduino and to program ESP32, in addition to the work we already do with Tinkercad, to show how you can do graphical programming and help kiddos to then grow more into the text-based coding, such as Arduino or MicroPython or Python or Java, etc. And so that using our robots, you're not restricted by any language or by any controller. That's when I know that we have a win. So I do a lot of benchmarking with robots, such as I have a Keys and an Elegoo robot that I'm benchmarking. I also have another ESP32 robot that I'm benchmarking, to always see how can we improve the flower bots, so to compare them to what's currently available on the market. So finally, we would like to thank Hackster.io for featuring our FlowerBot open source robotics for education, research, and service on the Hackster.io Spotlight. And if you would like to connect with me or our lab, here are a couple of ways that you can do this below, including our GitHub project page, websites, Hackster profiles, as well as social media. Stay STEMtastic.
Muting. There we go. STEMtastic. Amazing. So Dr. Berry coins so many interesting new phrases when she's doing her work. She's just like a social media genius. I wanted to show you that project as well. I'll remove this and add this. She mentioned that she's getting some students to work on the Pico 2, the Raspberry Pi microcontroller, and doing some edge AI stuff. So it's another time, great opportunity to mention that if you're doing this type of work, you should totally enter not only the giveaway, but also the competition that's going on for just a few more days until October 5th. Oh, my bad, September 30th. You can go enter that contest and see if you can win a trip to Taiwan, as well as many other cool things. You can, of course, also find Dr. Bear's tutorials, as mentioned before, on Hackster. So here's the one that she's specifically talking about today, obstacle avoidance. But she's also got another tutorial on here and is constantly publishing cool stuff all over the place. Our final talk today, I figured I'd make the servos go. He looks a little dead-eyed though. I'm a little sad about that, but we'll make it work. This is all a work in progress. Anyway, our final robot today is a personality having robotic office assistant called Betsy. What a cute name. Let's hit it.
Hello, everyone. I'm Dr. Norazmi Alias, head of Scuttle Robotics Asia. At Scuttle Robotics, our mission is to make robotics accessible, scalable, and impactful, not just for engineers to having fun in their work, but also for anyone who wants to create solutions in solving a real-world problem. Yeah. Today, I'm proud to share one of our standout projects called Betsy, the personal office assistant robot developed by Jorgen Trön. Betsy was developed as part of VIAM AI Challenge in 2024, where it won second place globally. So we are very proud in what Jorgen has delivered. The project focuses on something we believe is critical to the future of robotics, where we are looking at natural human-robot interaction, right? Instead of pressing buttons or typing command on keyboard, we should be able to simply speak to the robot and have it respond to whatever we ask it to do, right? So that's basically what we want to develop in this project, with Jorgen on Betsy. And so that you understand what we meant, regardless of accent, phrasing, or background, because we know everybody has a different way of saying things. And like I'm talking right now, it could be, a different accent, difficult for people from different part of the world to understand what I speak, and vice versa, right? So Betsy was designed to do exactly that: follow voice command, carry tools, deliver items, and help keep the workplace organized. We actually doing this inside our lab in Scuttle Asia, and all while understanding the context and acting naturally while people are working. So there's no really bad interaction between robot and human in the workplace. Yeah. So I think in order to explain detail about the work, we're gonna hand over this next section of this so-called presentation to Jorgen Trön, who led the development of Betsy, to share more about the challenges, the technology behind the project, and how Betsy is changing the way we think about the workplace, and especially in the workplace automation. So take it away, Jorgen.
Hello everyone, I hope you're all doing well. I'm Yogendran from Scuttle Robotics Asia, and today I'll be presenting to you a project of ours called Betsy, which is our personal office assistant robot. So let's go. So to introduce a little bit about myself, I'm a AI developer from Malaysia. I graduated from the Bachelor's in Information Systems and Artificial Intelligence from Raffles University. I have a deep-rooted passion for robotics and technology. And during my time in Scuttle Robotics Asia for my internship, I was able to dive deep and explore more into robotics and create various projects. And one of them was Betsy. So Betsy, in short, is a autonomous office robot that can see, listen, understand, and also act intelligently. We combine computer vision, speech, and AI reasoning to create a robot that can move around the lab and perform various tasks in assisting the people in the lab. So I'll explain much more in detail about Betsy in the upcoming video. So, but basically, to build Betsy, what we used was a Raspberry Pi and the Scuttle robot. And for the software, all we needed was the VM platform modules and integrate them with ChatGPT. And we were able to create Betsy with all of them. So I'll explain in detail what are the goals and challenges and the solutions that we came up with to build Betsy in the upcoming video.
Hey Betsy, introduce yourself.
Hello, I am Betsy, your personal assistant robot. How can I assist you today?
When we picture the future, we tend to imagine human-like robots simply integrated into our daily lives, found in our homes, schools, offices, and with whom we could interact with similarly as we would with another human being. To make this dream a reality, one crucial aspect is the ability to communicate with the robots in a natural manner. Hey Betsy, please follow me. When working with Betsy, there were two primary challenges that I faced. Firstly, as we all know, people naturally tend to pronounce words differently across the world. And this was a cause for inaccuracies in the transcription. The second problem faced was enabling the robots to understand and grasp the context of the commands presented to it, especially considering the wide range of speech patterns and expressions humans use. For instance, the command "fetch me a blue wrench from Fadula" can also be articulated in various ways, such as "could you please bring me the wrench that is blue from Fadula?" Ensuring Betsy understands this diverse range of speech patterns is vital for efficient human-robot interactions. To tackle both these challenges, I implemented a single solution which was leveraging on large language models. The choice stemmed from the large language model's ability to understand intended meaning despite minor errors in the input prompts, and the ability for LLMs to understand a wide range of textual patterns.
Hello, please go to Yogin's desk.
This is demonstrated when Fadula tells Betsy to go to Yogin's desk. Even though the command was transcribed as "go to Yogin's desk," Betsy was still able to carry out the task in hand. This is done by adding the functions within the robot's program into the knowledge base of the LLM and instructing it how to run the functions whenever necessary. This allows for an autonomous process where the audio input is understood by the LLM and actions are taken in the real world without a need for it to be explicitly programmed. Not only does this approach pave way to make robots more human-like, but also to make robots more accessible to be used by anyone around the world. Speech, as we know, serves as the most prevalent mode of communication among human beings. And throughout history, humans have developed countless of languages in which they've created various ways to express themselves through speech. Large language models have demonstrated promising advancements in the ability to capture this context. So, individuals of any language, age, or education level can effortlessly control a robot or any machine using this approach by simply speaking to it. In my opinion, this is where the combination between Scuttle and VM worked really well. While Scuttle offered me a robot base to get started with, VM made it easier for me to deploy all the services that I need and in configuring all the components that I needed for the project. For the Betsy project, I have used around 10 components and 5 services, and all of it just took me about an hour to set up. This allows developers like me to focus less on the problems with setting up the initial build for the project and more on coming up with innovative solutions to solve the problems that we have in hand.
So the next step for Betsy is to um, improve her navigation. We want to make Betsy better at detecting and also avoiding obstacles. We also plan on implementing a self-talking feature for Betsy so that she's able to go back to a station and charge herself. Make sure she's charging, and then yeah, we are quite also keen on adding robotic arms to her so that she's able to pick up, place, and move around objects around her, or perform any sort of interesting tasks, much similar to how a human would do. So those are the interesting things that are coming up for Betsy. So that's all from me. And I hope you guys really enjoyed our project, Betsy. And we really do hope that it serves as a beginner's guide on how to build a smart robot. And do check out our Hackster.io page for Betsy. We have tried to make it as in detail as possible so that anyone new here could also follow step-by-step instructions so that they can build their own smart personal office assistant. If you guys are interested, please follow us on social media as well. There's a link here to my LinkedIn and also Dr. Norazmi's LinkedIn, who's the head of Scuttle Robotics. He posts regularly about the updates on Scuttle Robotics. And yeah, do visit VM and Scuttle's websites as well to get more information on the various functionalities. And yeah, catch you guys later. Thank you.
Ah, so good. 4 amazing presentations from people doing really cool stuff with robotics, which is my favorite way to spend a Thursday morning. I also spent a bunch of yesterday working on upgrading Archimedes. Let's take a look at that project really quick. We've got Team Scuttle Robotics, and let's make this full screen. There we go. So not only have they published this tutorial about Betsy with the adorable face animations, which when it was doing the sort of like side to side, what do you call it? Perspective view of the face. I just thought that was wonderful. And their consideration for different accents. You know, one of my favorite comedy sketches from over a decade ago at this point, I think, is about some people trying to interact with a voice activated lift with Scottish accents. And so like this has been a known issue for a long time, and we're clearly still facing it. So I admire the work that they're doing to fix that so that everyone can participate in interacting with smart robots and building them. They've also published a couple of other tutorials, so you can find this one about the frame design. I'm going to close these as I go so that you people who are afraid of tabs, unlike me, will feel more calm. Anyway, more cool tutorials from the team. We've got this one about the frame, and then also another one about the power switch. Going back in time, again, we've got Dr. Barry's work with the Lilybot. I'm just going to cruise back through these tabs that we've opened and review what we saw today. You can go follow her. Also, go watch our Hackster Cafe episode. That is from a few years ago. Maybe it's time for a revamp. We got some really cool feedback actually in the comments from Dean Jones, talking about how you make robots and go into museums as well, but I think hers are more useful. I need to check her program out. And also get I think this was maybe representation being important. I never thought that I could be a scientist until I saw Stephen Hawking as a kid. Absolutely. I'm getting shade from my tabs. So it goes. Anyway, let's continue on. We're just cruising back through in reverse order. We've got the Orguino from Johan, who has a ton of weird projects on Hackster. I adore a strange project. It's really wonderful. And there's all kinds of stuff that Johan has also been working on, including a mechanical glockenspiel, tons of different music ones, as well as that real weird and fun voting one. We've got Nixon as well, whom you can follow on various social media according to his video, with this really cute little desktop companion robot with the little face that kind of reminds me a little bit of Anki and Vector and or the Anki branded Vector and Cosmo robots, which I think maybe got taken over by another company eventually. But either way, just a really cute set of facial animations, and even the way that it kind of flopped on the desk at the start of the presentation, I found really charming. Like, there's something about a robot needing help that is just, it's just adorable, and absolutely is the way that they will lure me into a false sense of security. uh, Come the robot revolution. So you can check out a bunch of other projects from Nixon as well. Tons more robotic stuff, as well as a cute little keyring camera that I've got to check out later. It looks so cool. Okay, so as you probably know, you have been watching Impact Spotlights. This is a monthly event from Hackster.io where it's no longer upcoming, but anyway, we have a different theme every month and have presentations from Hackster community members talking about their projects and walking us through them. It is a delight to watch these every time and get to see more people from the community that don't usually get space on our video channel. So love to see that. Also, if you're building robotics, be sure to join the robotics community. You can follow it here. You can also you can publish your projects to it as well. And then also, if you just add these tags to your projects, then they'll be automatically added, which is a little magic feature inside of Hackster. There's also a specific companion bots community, which is a place that I love to hang out. Always some cool new stuff. If you're building a robot that is designed to interact with people or do human-robot interaction, like this adorable chameleon robot that I just think is amazing, or Autobots, like were mentioned earlier by Dean, I think, in the comments, go add your projects to this community as well, and you can hang out with like-minded people. I said I was going to close these tabs, sorry. We've also got those ongoing contests. So, On the Edge giveaway going on until October 5th. You have 11 days left to win a couple of more prizes. I think there's one more drawing on the 29th and then another one on the 5th, plus that grand prize of the ultimate home AI server. Amp Up Your Workstation giveaway has just started up. We've got 1 month left on that one. Go check it out. I think this is launched in accordance with Autodesk University, which has just been happening, including this 3D printed, what does he call it? Hackster or something like that from Jeremy Cook. Anyway, super DIY guitar from a Hackster community member. Really cool and pro. Also, the competition going on through September 30th of Edge AI Earth Guardians. There's a lot of flexibility in this contest about what type of technology you can use and what type of topic you're addressing. So if you have any idea about how to use Edge AI in order to help the world, be better in various ways, no matter what concern you're addressing, go check that out and see if you can get an application in before the 30th. There's tons to win, and also just like lots of different options. Edge AI being specifically running on devices, running on the device, so that you're not using a cloud as well. Or if you are, that's not the main focus. Also, I mentioned our Pro program, of which I am a part. So, this is a program that enables you to not only contribute content to the Hackster community, articles, videos, etc., tutorials, all that good stuff in return for compensation, and you get to work with these amazing companies, and you get to state publicly that you have worked with these companies, such as AMD, Microchip, all these folks up here. It's just a really great program, and I gotta rep it because I'm a pro partner, and I think it is amazing. So be sure to check that out. It also opens up more of these options for different things that you can do in our contests and challenges. So closing these tabs. Also going on this weekend is Bay Area Maker Faire. Be sure to come by. You can get 35% off a day or weekend ticket with code CME, as I'll be giving a presentation on Sunday, which I forgot to mention, about mind-altering gadgets, which is a genre of technology that I build to help my brain work better. But also you can come meet Archimedes, and I'd love to meet you. I have collected a bunch of my specific Archimedes tutorials on here. on my webpage, but we have multiple write-ups of previous versions of Archimedes on Hackster.io, and I'm going to be doing another one for this new one, Frankenmedes, which is the one that you see before you and is currently trying to poke my eyes out because he is full of spite and is a diva. And finally, there's a really fun thing going on. Today, there is a launch of a new Raspberry Pi that I thought I'd drop in here real quick. Oh, we've got some comments coming in. No shade. Solidarity, if anything. Yeah. Really cool to see you folks coming through. There is indeed a companion bot group. And of course I closed the tab, contrary to my nature. This is why you never close the tab. So there is a companion bots group on Hackster.io where you can just subscribe and follow to see all the latest stuff that people are posting. And if we do more interactions with like specifically companion bot focused stuff in the future, then you can join. Also, MakerBlock, I know you're going to be at Maker Faire this weekend with your companion bots. I think I might have already given you a couple of Hackster pins. I'm not sure, but when this community first launched, we actually ran a little activation campaign, or whatever you would call it, where if people submitted their projects to the community, then we would give them Hackster pins. So I'll bring some along for this weekend just for you in case you don't have them already. And also, I'd love to see your projects on there. There's a cool returning project about EEG/meditation. Very interesting about that. Interested in that, please do send me the deets. Oh, the new Pi, yes. So, I sort of teased that a second ago. This is the Pi 500 Plus. It's not a robot, but it could be. I'm actually thinking about turning it into a keytar, but that's neither here nor there. But well, it is here actually. Check it out. It takes a second to go. Yeah. So just as a side note, this new Pi does that. It's got a fully programmable RGB LED backlit keyboard, powered and controlled by an onboard RP2040 chip. So it's built into that even before you put the micro SD card in. And then it's got really clicky keys that you can swap out with different keycaps. It comes with a key puller just for doing that. And then you've also got swappable NVMe storage on there, which you can remove using partially this spudger, and it makes some really satisfying clicks. I'm going to be releasing some more content about that because I just got an ASMR setup working, and you can find on Hackster's Instagram and other channels these various contents around it. I've made a little video already. There's another one coming up here. It's not going to let me open it because I'm not logged in, but stay subscribed to the Hackster channels for more on Pi 500 plus a bunch of other things that we've got coming down the line for you, as we've just described. I'm going to be publishing a bunch more of stuff about the Pi 500 plus, especially. You wanted it just for the keys. Keys are for everyone. Keyboards are for everyone. Rainbows are for everyone. You know, if you get excited about the backlit keys, I also think it would be cool to make some like custom 3D printed keycaps for this, since they make it so easy for you. In fact, I've never used a key puller before. I'm rambling. Okay, I'll get into that later. But that's the Pi 500 plus. Subscribe to Hackster on all the social media channels where you are, because we are there too, and you'll be able to keep up with the latest on Hackster stuff. Archimedes, do you have any final like thoughts here? Are you just gonna like keep moving around like a...
Thank you all for joining us today. May we meet again in the very near future. Oh, and hack on.
He said my catchphrase. He's a diva. It's my catchphrase, man! Okay, well anyway, hack on. And we'll see you next month with another set of Hackster Impact Spotlights. If you would like to be followed on featured on Impact Spotlights, then be sure to stay tuned for what the next the next month's theme is going to be. Publish your projects under relevant tags and reach out to the Hackster team on social media or wherever you can find them to just submit your interest. So you could be featured in the next Impact Spotlights as well. Thank you all for joining. It's always awesome to see y'all, and hack on, Archimedes. All right, see ya.